Hi, my name is Stephen Hall, and I'm the testing engineer at Earthrise Space Incorporated. It is my responsibility as the testing engineer to test all hardware and components to make sure it is safe to send to the lunar surface. As you can see, one critical component that we are testing currently is the lunar suspension system, the lunar lander suspension system, as I should say. This will be one of 4 suspension legs on our descent vehicle that will help our lunar rover and touch down safely. If you can imagine, this will be vertical, like this. This component here will hold our foot of our descent vehicle, and this will actually attach to the descent vehicle itself. This rig here will help to simulate positioning of these rods, how it will be on our descent vehicle to apply that load properly. And some ways that we are currently testing these components are to mount it on a rig like this and to apply loads at the pad joint ends and the supporting beam end, and with that compressive load it will help us to simulate an impact on the reason why impact would be so significant to our mission is because we're going to have to cut off our propulsion system a certain distance above the lunar surface. The reason why you can't use your propulsion system to actually land on the surface of the moon is because you're going to kick up a dust storm, and that's going to get all over our sensitive equipment and other components that we need to keep as clean as possible to work properly. So this suspension system will take the brunt of the landing force, and when we are orbiting the moon and slowly orbiting closer and closer, we will finally come to a point where our horizontal velocity is stopped and we descend vertically to a certain point, and then we will cut off the propulsion system and drop to the lunar surface. And this suspension system has to make sure that we could do that, and so we could get our rover off safely. So it's a very critical component to make sure it works properly. Some ways that we could test this would be an impact test, where you would take one of these suspension legs assembled to the lunar vehicle and simulate it dropping onto one leg. One suspension leg should be able to withhold the entire brunt of the force that we're expecting. The reasoning for this, if there's any error as we land onto the moon, the one suspension leg will be able to help us to land correctly in the case of an error. But obviously we have 4, we plan on doing it correctly and landing safely. Another way we can simulate testing on the suspension system is to apply a threaded rod through this component here, and as this component is turned and torqued through this, it will also load on this end, and as this is compressed, we get a general idea of how the compressive forces are going to be when we impact the moon. Another way that we test something of this nature would be with NI instruments and strain gauges, which I will show you in a second. Hi again. In this portion of the video, I will show you some National Instruments equipment that we're very grateful to be using at Earthrise Space. We have our breakout board, SCB68. We have our computer, PCIe 6363. We have our circuit board soldered with 3 Wheatstone bridges and 3 trimmer devices. These trimmer devices act as a electrical resistor, which with the turn of one of these knobs will change its electrical resistance. We have a aluminum cantilever beam with a strain gauge mounted on it. As you can see here, the strain gauge is also a electrical resistor and acts as a foil is deformed on the electrical resistor surface. It changes its voltage output. As the voltage output is changed, it is measured as deformation through LabVIEW, which is another NI product. We have our DC power supply, and we have LabVIEW. The reason why this kind of test is important is because we have to verify that our soldered electrical circuit works properly and that our LabVIEW is created properly as well. And a good way to do that is to mount a strain gauge to an aluminum cantilever beam, deform the cantilever beam, and that deformation should respond back to the LabVIEW as a voltage output, and from there the voltage output can be related to elongation of the deformed rod. And if I power up this LabVIEW, we get a signal. We also have voltage regulators back here that output 5 volts. Our DC power supply is giving us 7.8 volts. And what we tried to do here is initially balance the electrical circuit bridge by adjusting the trimmer and watching LabVIEW. As the signal becomes balanced and zeroed, as a Wheatstone bridge has 2 legs that need to be balanced on both sides, the trimmer on one side and the strain gauge on the other side. And as that's balanced, the deformation of the cantilever beam will respond as a voltage change on the LabVIEW. And once you have your LabVIEW zeroed properly with your trimmer, the deformation will read, normally it's a small voltage reading changes down to the 10th of a decimal place, and that would usually be microstrain from deforming the aluminum rod. So once we have our trimmers balanced for all 3 of our bridges with this technique of deforming the rod and seeing if we can notice any strain as we're straining this cantilever beam, we can balance all of our bridges properly, know that our LabVIEW works correctly, and then feel confident enough to mount our strain gauges actually onto our suspension system in locations where we feel it's necessary to monitor deformation, and also areas of concern where it would be more brittle and possibly have more likelihood to fail in certain areas. So we test those areas with the strain gauges and our NI equipment with LabVIEW. So once we have all these bridges balanced, we are set and ready to go to put the strain gauges on the suspension system, load it up as I described earlier in many different ways that we can, and we get our results from LabVIEW, which is recorded to an Excel file or something in that nature, where we can process our data, make design changes if necessary, and continue to move forward. So now that you're up to date on most recent testing at Earthrise Space, continue to stay up to date with us on Twitter at Omega Envoy, and like us on Facebook. Thanks.